Hello everyone, welcome to 3.1 Investigation Design. So as environmental scientists, you'll want to be able to go out into the field and collect some data about an ecological feature and then write a report about it. And this is the first step, is to plan your investigation. So when you're planning an investigation, you need to make sure that your methods and data are of a good enough quality so that they can be considered reliable and useful. So the first quality of our methods and data needs to be its accuracy. So our accuracy is how close to the actual value something is. Okay, so we're getting a accurate reading on what the actual thing is. So the next sort of quality of our data that we're going to look at is our precision. So the precision is the interval between results. So is it going to be precise enough? Are we recording in millimeters rather than centimeters, for example? The next thing it needs to be is representative. So this means that our small sample is the same as or representative of the complete data. Is our method reliable enough? So is it going to be giving us consistent, accurate results? Are we going to see, if we have a reliable method, anomalous results? Are they obvious to us? So anomalous results are ones that do not fit the pattern. And these aren't necessarily a problem because we're looking at natural systems and they are to be expected. But if we have a reliable method, we'll be able to identify them and most importantly, be able to describe why they've taken place. And if we do all of these things, we will have a valid study. And this means that it is precise, accurate, and reliable. And our results can be considered representative of the wider data set, and we can base our decisions off this data with confidence. So when we're planning our sampling exercise, we look at something called the Big Six. So if you ever get an exam style question where it's asking you to plan a ecological survey, then you need to make sure you're covering these 6 key points and answering the question using them. Okay, so we've got sample location, sample timing, sample size, number of samples, standardization of techniques, and statistical analysis. So our sample location to start with is what strategy we're going to use to avoid bias. So how we avoid bias. So we can either use random sampling, where we divide up our site into a grid and choose random locations using a random number generator to get a representative sample. Or we can use systematic sampling. And this is where we are using something like a transect. So it could be a belt transect, where we're taking a reading within like a meter square. This can be a continuous belt transect, where we do one every meter, or it could be an interrupted belt transect, where we only do it every other few meters.